Alright, hello, I'm Max, MQXF, my YouTube channel, amazing. This is a mod loader that I've coded in Rust, well, more so a macro that is still work in progress, but it has some amazing capabilities already. And this is for the mod loader for MVEngine, which is the game engine project that we're working on. It is already inside of MVEngine, and it contains both one for the game, which is like a macro for the game, and a macro for the mods. When you make a mod, you will provide a bit of code, which will be this code and this code as well. And the only thing that they will have to do is they will have to provide a mod init function. This function will have to be done anywhere inside of it, which is it's going to be provided like this by itself. And then the user can code their mod, well, their initialization function here. What I will do later as well is I will add more functions that will be publicly inside of librs, and then they can move wherever they want to write their mod. For example, I will have pub-fn mod update. Let's say there's some kind of mod update that needs to be happening. This will be here. It will be added to this macro over here, and the macro will figure out when to call it, and this will be shared between them. Now, there isn't much we can do between the mods by functions like this. This will be for the basic functions like initialization of the mod, maybe multiple phases of initialization, as well as the exit of the mod. The actual functions that need to be polled every once in a while should be provided through an API, the same way we provide an API over here. Over here, as you can see in the API, we have a function called sayHi. This function, sayHi, can be called on the API object. So how would you use this API to create a mod? So first of all, inside of your mod file, wherever it is, this is my test project, just so I can have a little setup script over here, which just builds it, moves it, and calls it. And in my library, I have a build, which builds it and then moves the SO file. The other important thing to note is that the cargo.toml under lib, I have to make sure that the crate type is a dylib. It is not a C dynamically linked library, which means every single new Rust version you'll have to recompile your mods. So, how does this work? First of all, we can define any kind of functions that we want down here. For example, I have an fn internal sayHi, which just has hello world. This macro is very, very handy because it allows us to basically do everything within one single macro. First of all, we define the API data type. This can be any kind of data type you want. This will automatically dynamically create it as a struct, and you also define a bunch of functions on it. For example, fn sayHi, which calls internal sayHi. Then you also can define, and this is optional as well, you can remove it and it will still be valid, except some of the functions down here will change. You can define a shared state. Here, the shared state has a player, which is a U8. Then you can statically store your state wherever you want. I'm using my own personal create once from my utility library, which is public, and and you have to store the state within an arc read-write lock. This is so that it can be shared and shared between the different mods. So at the very start of my main function, I create a new state where I set the player to 0. Then the macro provides a data type called mod. I can initialize a mod with a path of the SO file in which the mod can be loaded. This doesn't have to be SO. On Windows, it will work with the DLLs, and on Mac OS, it will work with dylib. We can unwrap this, but if we can also do other things. This returns a result with a mod or a string. The string is automatically formatted already to present what kind of error is happening. For example, if the SO file is not there, it will print out the fact that it's missing an SO file. If it could not open it with dlopen, it will print out we could not open it with dlopen. If the init function, which is defined over in here, is missing from the SO file, it will print out that the init function is missing. As you can see over here, it will say failed to load mod with the reason, and failed to get init function over here. Failed to load mod, function init not found. Then you can unwrap this if you want, or you can handle the error. I'm just unwrapping it here because for test purposes, it's perfectly fine. And this provides a wrapper for all the functions that are available. Currently, that only includes init, because that's the only function I've added. However, as I said, as I expand this, we can have other functions such as exit the mod. We also have a wrapper for getting the path to the mod, which is a string slice. So we can call init, and as you can see, it requires an arc read-write lock of state. This is only true if I include state over here. If I do not include state, it will actually, this init function will only take a self object because there is no state that is provided by the mod API. Now, in the library, I redefine the API and the state almost identically. The only thing I strip is the function definitions, because all we know is that the prototype. We do not know what's inside the function. We copy the state, and these two are just the names of the public static variables which hold them. This does, in fact, use my own custom create once API, which is going to be included in MVEngine anyway, so this is not a problem, and MVUtils is a very lightweight package. Now, this provides two public static variables, which I will actually make public right now because I forgot. And these two public static variables are the API and the state, which you define over here. The API is static and it cannot be changed. It contains references to the functions, and inside of it you can call functions on the API object, which will allow you to do this. And the state will be a read-write lock inside of an arc of the actual data that you share between the threads, or between the mods, I mean. We use arc just to make sure that multi-threading is an option, and read-write lock to make sure that there is no data races in case two mods are running on two separate threads trying to access data. In this mod init function, which is called inside of this macro, or reference inside of this macro, we call the say hi function on the API, and we write to the player field of the state object the value 10. Now, if we go to the main.rs over here, we see we initialize the player with the value 0. However, if I run it, it prints out hello world due to the fact that it calls say hi on the API, and it changes this, the player value to 10. So this is an initial demonstration of the mod loading API. It is very simple. It is not that big. It uses the lib loading crate and my own MVUtils crate, and it ensures as much safety as I can ensure without adding any additional safety checks. It is fully compatible with Rust type system. It makes a custom type for the mods and API and state. As well as this, I can in fact share more different variables through other functions like the exit function, the update function, all that stuff. Those functions will be done later. I will in fact add them. And other than that, that's everything I have to show for now with the mod loading API. I will add an extra safety check in later, which I will show off again. The safety check that I'm planning to add is one to ensure that the mod has not been tampered with externally after downloading. Thank you so much for watching, and this is the first update of MVEngine.